what we have done till now, we are done with 5 processes of time management. Now, this particular process is a develop schedule. It uses all those processes or an output from all those processes as an input. So let us look at the sequence of processes in a time management. The first thing which we do in a time management is that we develop schedule management plan. After that, we do identify activities. So we do a defined activity. So we get the list of activities. After getting these activities, we can work on estimating the resource requirement, or we can also work in a parallel to identify the sequence of these activity, and the sequence of this activity gives us project schedule network diagram. Project network diagram. Now, after identifying the resources, or after estimating the resources, not identifying, we estimate the activity duration. And now here we are. We do a develop schedule. Now, the develop schedule is a process or a last process of planning in a time management. So last, because it compiles or it aggregates all the planning activities which has been done in project time management till now, and this project schedule, a develop schedule, gives us an output which is a schedule where we can identify that this activity would be done by which person, and we can also identify that when, at what date do we expect a start or an end of this particular activity. Now, when you look the develop schedule in PMBOK, you may find that there are 13 inputs, and you get worried about that how to memorize them. And I always tell, no need to memorize inputs and outputs, you just need to visualize the process. Now, what we have seen here is that the 5 planning processes of time management are feeding to develop schedule, and that is how their outputs are feeding to develop schedule. We use, in a develop schedule, we use schedule management plan as an input. We use activity attributes as an input. We use activity list as an input. We use activity resource estimate requirement as an input. We also use the activity duration estimates as an input. Now, the resource requirement is also given in the form of resource breakdown structure. So that also becomes an input to a develop schedule. Activity duration estimate is as an input to our develop schedule process. Now, the output of sequencing activity, the project schedule network diagram. So schedule network diagram is also works as an input to develop schedule. So in total, we get 1, 2, 3, 4, 5, 6, 7 inputs out of 13 required inputs from the time management process itself, because as I said before, develop schedule aggregates all the time management planning activities. So what beyond time? So we need to know information about resources, because develop schedule gives us who would be working on what. And in order to get the resource information, we look at resource calendar, as we were looking in our previous processes also, because resource calendar tells us that which resource is available from which duration to which duration, which can be allocated here. We also get project staff assignment. Now, this is a new input which we are using in time management, and this input is coming from human resource knowledge area, and it is telling that which are the people, what are the resource, the staff, the people allocation to the project. And this is a required input, so because without it we cannot map activities with human. Till the time we were estimating activity resources, we were more focusing towards the type of resources we need, but in a develop schedule we give them the name, the individuals. We try to put maximum number of individuals to the project schedule. This gives us people information, this gives us time information. So we got time information, we got people information, and then we look at our scope, because scope statement always gives us assumptions and constraints. So these assumptions and constraints need to be taken care while we are developing the schedule. What else? While we are developing the schedule, we also need to take care of risks. So we look at our risk register. And as usual, we also need enterprise environmental factor to know which all software, which kind of scheduling mechanisms are available or tools are available in an organization, and we look at organization process assets, which gives us historical data as well as templates. So this should make the total of 13. So we got 7 inputs from time management, we got 2 inputs from a resourcing point of view, so 7 plus 2, 9, we got scope which make it 10, we got risk which made it 11, and then these 2. So this is how the 13 inputs are taken care while developing the project schedule. Now what tools and techniques do we need to convert these inputs into a project schedule? The schedule network analysis is the first tool which comes in our PMBOK. The schedule network analysis talks about applying critical chain or critical path method to identify critical path method or critical chain method to identify start and end dates of various activities. It talks about that how are you going to optimize the resource utilization to develop and provide a schedule which is optimized, and the schedule would be having the start and end date of each and every activity where the resource is also associated. Now what is this critical path method? The critical path method takes an input from schedule network diagram. So the project schedule network diagram which we have plotted using activity on node was having dependencies. Now in critical path method we also feed information related to duration into it and resources. So resources are coming because in a project schedule both informations are needed, but for identifying a critical path or applying a better way of doing project or organizing the activities so that we can do the project in a least possible time frame, we also feed the duration information along with these activities. Now with these duration estimates we identify early start, early finish, late start and late finish of each activities. Now how do we identify that? We start with the first activity, then we add the duration and we do a forward pass, and by doing a backward pass we identify the late start and late finish. And the critical path of a project is a path where we have early start and late start are the same, where we have zero flexibility, or you can say the critical path is a path of a project which is the longest path in a given project, but that defines the shortest possible duration for a given project. So we will handle the critical path method in a separate video where we will get into the details of how to calculate the early starts and how to calculate the late finish, etc., and how to calculate a flow. But for the develop project schedule process, we just take an overview of critical path method because it's an essential tool and technique in order to identify the project or in order to develop a project schedule baseline. The third method or third tool and technique which is used in develop schedule is critical chain method. Now critical chain method is a type of scheduling technique which focuses on resource constraint optimized schedule. It also removes the contingency buffers from the activities. While we were making a critical path, we were taking activities and these activities were having their contingency buffers as well. In case of a critical path, critical chain method, we remove all these contingency buffer and we put the buffer as a separate identity. So for example, in this, by using the same activity schedule network diagram, if we plot it using a critical chain method, we may plot it like this. So we may add a buffer. We may add a buffer here. We may add a buffer here which helps us. So what we do first? First we remove all the buffers from the activities. So the activities which were maybe estimated 5 days here may get estimated as a 3 days in a critical chain method, because we remove the contingency reserve from that particular activity element, and we put these contingency reserve at the end of the path in form of a feeding buffer. So there is a two terms which comes into the picture when we talk about critical chain method. One is a feeding buffer, and another is a project buffer. So what we do, we estimate the duration of activities with a 50% probabilities, and we understand that there is a good amount of probability that these activities will not finish in a given estimated duration. In order to manage that probability not finishing in a given amount of duration, we use the buffers, and we monitor that how much percentage of these buffers has been utilized or consumed at a given particular point of time. So a lot of monitoring happens by monitoring these buffers. Now till now we were looking at time dimension of things, like we were arranging activity in a sequence and trying to identify how much time it will take, and we were assuming that things will be done and we have enough resources available. Now the further tools and techniques which are involved in developing a schedule is resource optimization. Now resource optimization is a tool and technique which focuses on optimizing the allocated resource. And in this tool and technique we have a two further type of tools and techniques. One is resource leveling and other is resource smoothing. Now, resource leveling can change the critical path, but resource smoothing will not change the critical path. What is resource leveling? For example, like while we are making this critical path, we find that these two activities are parallel, and we know that these two activities can be done by X person, and we may end up allocating the X person for both these two activities. Now, when we look at the allocation, when we look at the resource histogram where resource is plotted in a bar chart and where we see that one resource is allocated for how many hours in a given day. When we look at a resource histogram, we find that at these particular resources are over allocated. So resource histogram shows that this is my leveling level, for example 8 hours in a day, this is my leveling layer, but out of this critical path, many of the resources are going above the defined limit. Now, the resource leveling is an optimization technique where we try to remove these spikes and try to normalize the resource loading across the project duration. Now, the other technique is resource smoothing. Whenever we have a slack, so since when I was talking about critical path, I was saying that critical path is a path where we do not have a slack, where we do not have a flexibility, because if we delay any of the activities in a critical path, the complete project gets delayed. But there are other activities which are not on critical path, and the activities which are not on critical path has float, means they can delay by the amount of float without impacting the project end date. Now, in order to use resources effectively, we may decide to delay some of the non-critical activity by a given duration so that we can utilize our existing manpower in a better way. The next tool and technique is modeling technique. Now the modeling technique, this technique talks about that we look at various alternatives. We do a what if analysis. Now, the development of schedule is not a very straightforward process. It's not like that we put the activities against people and we put the time dimension and we get the schedule. as an expert, the person who is preparing the schedule may need to look at various scenarios. He can look at various ways of organizing these activities, various ways of organizing or allocating resources to it, so he gets the optimized schedule. Optimized schedule may not necessarily be the shortest schedule, but could be optimized from resource point of view, because you may feel that resources are constant in your organization. You want to prepare a schedule on the basis of 100% utilization of those resources. So what basis, what guidelines you will use for optimization of your schedule is documented in your schedule management plan. According to schedule management plan, you apply a modeling techniques where you do a what if analysis, or you identify alternatives, and you also can run a simulations. Now, whenever you hear of a simulation, you got a Monte Carlo technique. Now, by way of simulation, you want to say it here is that every activity has an uncertainty attached to it. Because there is a standard deviation which reflects the difference between the pessimistic and optimistic duration for a given activity. Now, this standard deviation also helps us in telling the accuracy level. For example, if we add more standard deviation into a contingency buffer, we get a better accuracy. Now, by using various simulation technique, we can look at various possible combinations, and we can identify that at which particular certainty we can say that this project would be finished in a given date of time. So we put a simulation technique, we use some amount of sample data, we put them in our project schedule model and identify the possible outcomes. After this, we apply a technique called lead and lag. This we also discussed during sequencing activities. It is like, as I said, while making a sequence, we were thinking that one activity, for example, if you have a finish to start relationship, we were thinking that after finishing the other activity should start. But if you want to delay this, or if you want to make it early, we can use lead and lag. We also apply another tool and technique, which is schedule compression. Now we also have a separate video on schedule compression where we are talking about how to compress the project schedule by doing fast tracking or crashing. Now the schedule compression technique is, in a fast tracking, we try to overlook the dependencies. We try to do these things in parallel if this is a critical path. And because we want to do things in parallel, and there is a risk of rework when we do things in parallel. When we do a crashing, we don't compromise on dependencies, but we try to reduce these durations by putting more amount of resources. So amount of crashing or fast tracking needed in a project is driven by the various business conditions. For example, if you have a need of finishing a project in a given time frame, you may want to invest more and take some of the schedule compression technique into an account. Maybe you apply both of the techniques at a different part of your schedule network diagram. Now you might have realized that we have many tools and techniques, and we have a huge amount of data to take care in order to develop the project schedule. Now for that, we may need to use a good software, some tools which can help us in creating the schedule model once we feed all the required information, once we feed all the required dependency in it. And that makes the 8th tool and technique of develop schedule, which is a scheduling tools. So we can use various tools for managing this complex need of develop schedule. Now we are done with tools and technique. So what we get out of it? We get a project schedule out of it. We get a baseline project schedule out of it. So the output of develop project schedule is schedule model, which gives us a baseline schedule. It also gives us a project schedule. So what is the difference between project schedule and baseline schedule? So baseline schedule is one instance of a project schedule, like we discussed that from a schedule model, we pick the instances and we mark them. So project schedule is always a current schedule which we have in our model. The baseline schedule is one reference model which we will use for comparing, for monitoring and controlling purpose going forward. So out of one, when we are doing a planning for baselining purpose, the instance which we get out of this exercise, we mark it as a baseline schedule, and in general we keep doing the updations and keep doing alternate analysis, and always we get a project schedule out of this exercise. Now project schedule can be represented in the form of bar charts, also known as a Gantt chart. It can also be represented in the form of milestones list. It can also be represented in the form of just list of the activities. So depending upon the stakeholders, the communication need, we use a view of a project schedule. For example, for senior stakeholders, the stakeholders who wants to know the status at a top level, the milestone chart may work best. Now the project schedule or the baseline schedule is substantiated by schedule data and project calendar. Now schedule data is a database. You can think like that a project schedule is an instance of our exercises of our schedule. The schedule data talks about the raw element, the data which we have inside the schedule, which is giving us the project schedule as an output. We also have a project calendar. Now till now we were talking about resource calendar. Now from a develop schedule we get an output called project calendar. The project calendar talks about the allocation of resources inside the project against the time frame. It also talks about what are the working days of the project, in which particular shift you will be working during the project. So the timetable, the resource allocation against the time also get reflected in a project calendar. Since we are preparing the schedule, we are baselining the schedule, this baseline schedule also goes into project management plan. So the project management plan contains the baseline schedule. The project management plan gets updated as an output of develop schedule. During the develop schedule, if you identify any change in a schedule management plan, that also get documented or get compiled inside the project management plan. So as an output of develop schedule, we get a baseline schedule, and this baseline schedule is also a part of project management plan. So in that way, we also get a project management plan updated. We may update various project documents like risk, activities, assumptions, etc., etc. So various project documents may get updated during as an output of develop schedule process.